Okay, so I'm going to be redoing the critical compressibility video, or the critical polynomial, the compressibility polynomial video. That's the one I'm going to be redoing. Okay, so we have all of our equations here, and these will help us out later to turn this into a polynomial. So we have first got to convert this all to z. So multiply everything by both sides by PBRT, or no, v over rt equals RTV over RTV minus b minus AV over RTV plus epsilon b times v plus sigma b. And then these RT's cancel out. And what we're going to want to do now is get volume out of everything. So, or take a factor of volume out of everything. So then it'll be z is equal to 1 over 1 minus b, 1 over 1 minus b over v minus, and then here we can take out actually 2. So we're going to take out 1 from this, and then we're going to take out another one from this, so it'll cancel out this v at the top and add another one down here. So that'll be 1 minus, and we're just going to put it all up here, a over RTV times 1 minus epsilon b over v times, or no, 1 plus epsilon, and then 1 plus sigma b over v, to find that better. And so we have then replace all these v's with rtz over p, and so that way you've got, let's go put it over here, z equals 1 over 1 minus b, no, just regular b rt, no, bp, because it's going to be, those are going to be on the bottom, bp over rtz, and then minus a over r, no, ap over rt, r squared t squared. Yeah, AP over R, yeah, that's what that is. Oh, R squared T squared Z. Okay, over 1 plus epsilon BP over RT times 1 plus sigma BP over RT. And then we have this beta here. We can convert anything that's BP over RT into beta. So that will make these E beta, sigma beta. This top term is going to be A times P over RT times B over RTZ. No, that's 1 over RTZ. And then this right here, if you can even see it, this AP is P over RT. This is equal to B over beta. So this is B, no, beta over B, because you're just missing this one B here. So then we have A beta over RTZ, and so that we can use Q, so then it becomes the ABRT, no, this is BRTZ. So then A beta over B, this is going to be just Q beta over Z. So it's, let's just Q beta over Z. And our new equation is going to look like, because I already have it partially there, but I'm going to just write it more clearly. Z is equal to 1 over, oh, I forgot to change this into beta. My bad. So this is going to, this BPRZ is going to just be beta over Z. Okay, so it's 1 over 1 minus beta over Z minus Q beta over Z times 1 plus epsilon beta times 1 plus sigma beta. And what we can do here, see there's z's everywhere. We can multiply or divide everything by z on both sides. So that way we can take a factor of z out here. If we multiply a factor of z on the bottom of everything, so it's over z, that becomes 1 is equal to 1 over z minus beta minus q beta. And since there's z's here, since there'll be two z's here, we can distribute one z to one of the I don't remember exactly what you call these, but one of the multipliers, and another z to the other multiplier. So that way it becomes qb over z plus epsilon beta z, and then z plus sigma beta z. And from there, what we're going to do is try and get these two to have a common denominator. And to do that, we need to multiply this top here by this. So this will be this by this, and then just cross multiply essentially. Well, not cross multiply the denominators. So I'm going to do that, and it'll be, well, first let's multiply this polynomial out. So this polynomial is, just free up some space. This polynomial is going to be z squared plus epsilon plus sigma z beta plus epsilon sigma beta squared. And so that's what that is. And then we have to multiply z beta times this for the bottom. So we just get times z minus beta. We get z cubed plus, no, z cubed. Oh, let's just do all the plus terms first. Z cubed plus epsilon plus sigma beta z squared plus epsilon sigma beta squared z minus z squared beta minus epsilon plus sigma z beta squared plus epsilon sigma beta cubed. No, minus, because it's all minus. Okay. So that'll be what's on the bottom. What'll be on the top is just this polynomial minus z times b minus, well, this might as well q beta z minus q beta squared. Q beta z minus q beta squared. So what we have then is, I'm just going to erase this and set this equal, no, I can erase this first and just write it that way. So that way it's 1 equals, and then the top part is z squared plus epsilon plus sigma z beta plus epsilon sigma beta squared minus q beta z plus, because it was a minus beta that you were multiplying by, plus q beta squared. And then from there we can multiply this denominator to this side and shove everything over to the denominator side and set it equal to 0. So doing that, you get z cubed plus epsilon plus sigma. I'm not going to even bother. I'll just write this and cut this out because it's gobbledygook. Okay, and this is where it'll get a little tricky because this is going to be minus z squared minus epsilon plus sigma z beta minus epsilon sigma beta squared plus q beta z minus q beta squared. And from there, well, I'm just gonna, and this is equal to 0, so from there I'm just going to group everything. So it's z cubed, and well, actually let me search all the terms first. 1, 2, 3, 4. Okay. So z cubed plus z squared times, it's going to be, let's put these in terms of betas, epsilon plus sigma beta minus beta minus 1. And then plus z, in terms of the betas, it'll be, let's do the pluses first. Q beta plus epsilon sigma beta minus epsilon plus sigma beta squared minus epsilon plus sigma beta. And that is just going to be, and then there's all the regular terms, which there's only 3. So there's minus q beta squared minus epsilon sigma beta squared minus epsilon sigma beta cubed equals 0. And there we have our cubic compressibility polynomial. That's a long one. So this is, we use this in some future videos.